Antimatter. It sounds like the perfect fuel. If 1 gram of antimatter meets 1 gram of ordinary matter, it would release about 43 kilotons of TNT. That's roughly 3 times the explosive energy of the Hiroshima bomb. Almost all the mass disappears and becomes energy. That's why Star Trek uses antimatter to power its starships. Matter and antimatter collide inside the warp core, releasing the enormous energy needed to bend and warp space. On paper, it's a beautiful form of energy, but in reality, antimatter comes with some brutal problems. We cannot drill for it. We cannot mine it from an asteroid, nor can we scoop huge amounts from endless lakes in the middle of space. Microscopic traces appear naturally in cosmic rays and around some planetary magnetic fields, but nothing close to the quantity needed to fuel the insane energy demands of a starship. The brutal reality is, if we want antimatter, we have to make it. Today, we use ordinary energy to accelerate particles to enormous speeds and smash them into a target. A small fraction of those collisions creates new particle-antiparticle pairs. Scientists then have to find the antiparticles inside a storm of debris, slow them down, capture them, and keep them from touching anything. At every stage, the process loses energy. Most collisions do not produce the antimatter we want. Much of what is produced flies in the wrong direction or at the wrong speed. Then, more energy is needed to cool it, control it, and hold it inside powerful electromagnetic traps called Penning traps. Einstein's equation works in both directions. Energy can become matter, but the bill still has to be paid to the laws of thermodynamics. There is no way to avoid it. This makes antimatter less like an oil well and more like a battery. A battery doesn't create energy. It stores energy that came from somewhere else. Antimatter could store more energy per kilogram than anything we know, but today it would return only a tiny fraction of what we spent producing it. Even CERN's incredible progress shows how far away we really are. In 2025, the Alpha experiment produced and accumulated over 15,000 antihydrogen atoms in under 7 hours. This is considered a major breakthrough. But 15,000 atoms have a combined mass that is so small that it's almost absurd to express in grams. We are not filling fuel tanks. We are literally counting atoms. There are about 6.02 times 10 to the power of 23 antimatter atoms in a single gram of antihydrogen. That's 602,000 billion atoms. CERN produced only 15,000 over 7 dedicated hours. Now comes the problem of storage. Antimatter cannot sit inside an ordinary metal container. The instant it touches the wall, it annihilates. Charged antiparticles can be suspended with electric and magnetic fields. Neutral antihydrogen can be held in specialized magnetic traps, but only within an extreme vacuum and carefully controlled conditions. But the containment equipment can weigh far more than the antimatter. It consumes power continuously and would result in an utter catastrophe if the systems break down. A Federation starship carrying hundreds of thousands of kilograms of antimatter would be carrying a pending disaster inside its hull. A containment failure wouldn't produce a nice, orderly engine shutdown. The fuel would touch the ship and begin releasing its stored energy immediately. Star Trek's warp core breaches are dramatic, and the danger is real and understated. Using the energy antimatter releases is another problem. Annihilation does not produce a convenient stream of electricity. It creates high-energy radiation and fast-moving particles. Some could be directed for propulsion, but much of it would require extremely heavy shielding. Turning that violent spray of gamma radiation into useful electrical power would introduce even more losses and a tremendous amount of waste heat into the millions of degrees. Some science fiction universes solve these problems by inventing a fuel that nature has already packaged for us. Battlestar Galactica has thallium, a mineral that can be mined, refined, and loaded into a ship. Star Wars has hypermatter, an exotic fuel used in immensely powerful reactors. Coaxium is a very rare and highly volatile form of hypermatter, essential to hyperspace travel. It can be mined on Kessel, transported and refined, although mishandling it can cause a catastrophic explosion. These fuels are 100% fictional, but they solve the most important economic problem. Their energy is already stored as a natural dormant substance that contains unimaginable amounts of power. These sci-fi civilizations do not have to manufacture every gram from pure energy before their journey begins. Star Trek antimatter does not have this level of convenience. The Federation still needs an energy source. The warp core may be a magnificent fictional engine, but somewhere behind it must be an even larger energy industry to make the antimatter fuel. If the Federation can manufacture antimatter by the ton and afford to lose most of the energy used to produce it, then it must have solved energy scarcity long before it ever turned to antimatter as a fuel. Antimatter is the blueprint for the perfect fuel. It's real. We know how to make it, trap it, and release its energy. But we cannot harvest it because it doesn't exist naturally in any usable quantity. Storing it is difficult and expensive, and producing it costs vastly more energy than we get back. Antimatter isn't free power. What it is an almost perfect container. Similar to the lithium battery powering your electric car, power that we already paid for and created. The reality is, we could not afford the massive energy bill from the laws of thermodynamics to create any significant amount of antimatter.